There I was, taking a walk on a cold winter's day, enjoying the winter scenery, when I stumbled upon a little kid picking up all the snow. So I asked him, "What are you going to do with all that snow?"
I'm saving it. Did you not hear? The weatherman said global warming. It's our last snow this year. I need to save it.
The little boy brought the snow inside to save it. But oh no, he left it on the counter.
When the boy brought the snowball inside, he wanted to find the volume of the snowball. So he used the volume of the sphere formula 4 over 3 pi r cubed to solve for the volume of the snowball. He measured with a ruler. The diameter was 9 inches. He knows that the diameter equals r over 2. So he plugged in r over 2 and got 4.5 inches for the radius. Then he plugged into his volume formula 4.5 for the radius, which got him a volume of 381.7 inches cubed. Then the boy wanted to know how much the snowball would melt if it got left out. He found the derivative of the original volume of the sphere, which equals 4 pi r squared dr over dt. He knows that the rate of change of the radius is negative 0.5 inches squared per minute. He plugged in negative 0.5 for dr over dt, and he plugged in 4.5, the radius, for r. He then solved for dv over dt and got negative 127.23 inches squared per minute, because the volume is decreasing as it would be melting. Go. What happened to all my snow? I need to save it. Hopefully the freezer will keep it cold.
After the boy puts the snowball in the freezer, he's amazed that there is some snow left. So he uses calculus to determine why there is still leftover snow. He first finds his new radius by using the minutes that have gone by 5 and the rate of change for his radius of negative 0.5. He figures out that 2.5 is his answer, and he takes that from his original radius and gets 2. He then plugs that into his volume formula to figure out the volume of the snowball. Uses the equation 4 over 3 pi r cubed and plugs in his radius of 2 and gets 33.51 inches cubed. He then, to determine the new rate of change, because he figures that there must be a new one if there is some snow left, he finds the derivative of our original volume equation again of 4/3 pi r cubed and gets 4 pi r squared dr over dt equals dv over dt. Then he plugs in his value for radius and his change in radius of 2 and negative 0.5 and calculates all that out to be 25.133 inches squared per minute. And that becomes his new change in volume.
So after he solved for both the original snowball and the snowball after 5 minutes, he wanted to see how much his snowball lost. So he put his new value, 33.51 inches cubed, minus his original, which was 381.7 inches cubed, and he found that his snowball lost a total of 348.19 inches cubed. And then he wondered why he still had snow left, because his original dv over dt was negative 127.23, and he was confused why there was still snow after 5 minutes. So he found that it decreased from 127.23 inches squared per minute to negative 25.133 inches squared per minute. And this is because as the snowball was getting smaller, the amount that it could lose was less. That is why his derivative of the original snowball is more than the derivative of the new snowball. I think we just saved the snow.